Question number 9. What do we have here? Question number 9 looks pretty interesting. It says, in the diagram, right? DE is a tangent. Okay, yes, we have a tangent here. So it's a tangent to the circle at E. Perfect. And then what does it say now? It says DFG. DFG. So there's like DFG here. DFG here is a straight line, right? And I mean, like, according to the sketch, these are equal. Okay, interesting. And then they told us that, yeah, DE is equal to EF, fine. And then they told us that, what? Oh, it's also equal to FG. Where's FG? FG is equal to DE, which is also equal to EF. Where is EF? Oh, there's no line there, but the statement told us that DE is equal to EF and it is equal to FG. That's interesting. That's very interesting. But anyways, it says here, what does it say there? It says the following. It is further given that DF, okay, where is DF? DF is this line. DF over DE is equal to Y. So what we can interpret it as is, if they tell you that DF, right? DF over DE is equal to Y over 1. If they do that, you see, if they do that, then, I mean, they're giving us maybe a ratio that we can work with, which is good, I guess. And then the next thing they said is let DEF equal to X. So DEF equal to X. This looks super crazy familiar as well. Like, man, so much recycling of questions. Oh, well, we'll have to see it, I guess. So the 3-mark question says give 3 other reasons equal to X. Give with reasons 3 other angles equal to X. Well, I mean, like, this is a tangent and this is a chord. So this is also equal to X, you see? 10 chord theorem. Because you see there's a chord here. So the angle subtended by this chord is the one equal to the one at the tangent. So let's tell them that G is equal to DEF, which is technically equal to X. The reason is 10 chord theorem. We love to see it. We love to see it. Okay, so the idea is once you find something equal to X, you see, you trace it. So here, this X is going to be equal to this X because they are angles opposite equal sides, you see. So here, angle G is equal to FE2. The reason is angles opposite equal sides. Great. Now you can even look for an angle equal to this one, but if you don't find it, I guess it shouldn't be too bad. But the other thing is, if you think creatively, right? Remember, you have this exterior angle here. This exterior angle over here. This is an exterior angle, right, of this triangle here. So if you're looking at this triangle, right, the one angle there is equal to X. The other angle there is also equal to X. So this one is technically 2X. Now, if this is 2X, this is also going to be equal to 2X because they are angles opposite equal sides. But I'm wondering to myself, why did they mention that that is equal to X? Well, oh, the other one that's equal to X is blunt. It's this one. Alternating angles. You probably saw it earlier. So I just said, to catch up. This is equal to X because these are alternating angles. So E1 is equal to F2 alternating angles. E1 equal to F2 alternating. Well, bro, come on. Alternating angles. Alternating angles. So the next one says we should prove. Are we proving? Well, 9.2.1 EH is equal to EH over HY is equal to Y. So I'm assuming I have to prove. That's the only thing that makes sense here. EH over HY. Where is EH? EH. Oh, EH over HG. Okay, the other one we had was DE, not DF. Right, DF over DE. But that doesn't really mean a lot. That doesn't, we should actually just use this question to help us, or the statement, because firstly, this is a how many mark question? It's just a 3-mark question because there's no heavy lifting. Remember, they told us that was it DF or DE? Yeah, they told us that DF over DE, right? DF over DE is equal to Y. This they told us. However, if you look at the lines that they're talking about, right? DF and DE, they don't really help us to show that this over this is a Y also. What can help us is the fact that DF over FG is equal to EH over HG because of the proportionality theorem. So let's actually just do it. DF over FG, right, is equal to EH over HG. So the reason for that is just proportionality theorem. So let's write that down. DF, is it DF or D? Yeah, DF. DF over FG is equal to EH over HG. This is a fact. The reason is just going to say here proportionality theorem, prop theorem. So this being said, what we need to tell them, right, is the fact that FG is equal to DE. You see, FG is equal to DE. That's a given. You see, FG is equal to DE. They gave it to us. So as long as FG is equal to DE, we can say therefore DF over DE, because replacing this with DE, right, since they're equal, is equal to EH over HG. So here, therefore, EH over HG is equal to Y, because DF over DE is also equal to Y. This is something they gave us. You see, we could even, if you said, we can even just drop here given. It's a given statement. Then from there, we were able to do all we did here and show that this is also equal to Y for 3 easy marks. The next thing is, let's see what we're going to do next. Spice up the colors a bit. Orange, orania. So they want us to show that D is equal to 72 for a 4-mark question. Well, the crazy thing with this kind of a question is that we don't have any dimensions, but they want us to show that D is equal to 72. If D is 72, right, it means that X would be equal to 36 some way, somehow. Because remember, we have shown that D is just equal to double of whatever X is. We showed it, you see. Exterior angle of a triangle is equal to the sum of the opposite interior angles. So if this is 2x, this is 2x. Actually, we can show that this is 2x because of exterior angle of a cyclic quadrilateral. And then we can say all these angles add up to 180, right? And then we solve for x. And then we'll be good to go with the angle D. So let's start with F1. F1, we're going to say it's equal to E2 plus G. That's what we're going to say. Let's tell them that F1 is equal to E plus G. Is it E1? Which A? It's E2. E2 plus G, right? Then here you're going to say exterior angle of a cyclic quad. I mean, exterior angle of a triangle. Exterior angle of a triangle. So with this exterior angle of this triangle, right, we need to keep in mind the following. E2 plus G. What do we get there? It's going to be F1 equal to E2, right, is X. This is also equal to X. This is 2X. That's what we have gotten for F1. Then we're going to tell them that F1 is also equal to D because they are angles opposite equal sides. F1 is equal to D, so it means it's also equal to 2x. The reason is angles opposite equal sides. So here now we can say therefore 180. I mean, here we don't even have to say therefore. We could actually just say therefore because I'm like, it's more of like what we're carrying on. So here we can say D plus E1 plus F1. D plus F1 plus E1. This is equal to 180. The reason is interior angles of a triangle. And if you put the dimensions for each of these, it's like what? D is 2x. This is also equal to 2x. This is equal to x. And then if you solve for x, there's like 5x here equal to 180. What? Yeah. And then divide by 5 is going to give you 36. Well, what am I doing? X is 36. And then here, therefore, D is equal to 2 times 36. You see? 36. And then you're going to have here 72. They'll give you a whopping, how many marks? 4. If they had made it 5 at least, but oh well, we got our answer, so we really don't have to cry too much. And then they want us to prove similarity between triangles for 3 marks. DGE. We need to prove that it is similar to DEF. DGE, DEF. D, G, E, and D, E, F. Awkward. Not gonna work. See that again. DGE. There is D here. There is G here. Oh yeah, it is gonna work because this is X and X, so that makes 2X. And then there's this angle 2X, and then the single X for the big one. For the small one, there's a single X, double X, double X. Oh yeah, that's super simple. That's like super simple because we're talking about this small triangle here. We're talking about the big one. And the way we have laid it out, that's why it's a 3-mark question, because there's really not a lot of heavy lifting here. Because with proving similarity, you just have to prove that all 3 angles are equal to each other. So firstly, we can just state, if you're going to prove that these are similar, right? We can say that G is equal to, wait, what? The G here, right, is equal to the E1. That's been proven a long time ago. This has been proven. Now we can say that, what you may call, we need to tell them that, well, I mean, like this angle is equal to 2, this D is a common angle there. So that's fine. Wait, D is a common angle. Yeah, they both have D. See, the big triangle, the small one, they both have D there. So I'm kind of interesting. Oh yeah, so here D, let's go to D, common angle. Common angle. So you've shown that 2 pairs of angles are equal, right? So the third pair, you can say it's equal because of interior angle of a triangle. So we used E, we used D. Now we can just say F1 is equal to the whole of angle E. F1 is equal to the whole of angle E. So we can just say interior angles of a triangle. So here we can say, therefore, these are similar. Triangle D, GE, GE, similar to triangle DEF. The reason is angle, 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 angle. Great. So this is good. We move on now. We keep moving forward because why not? So here with this being said, we need to prove that DE squared is equal to DF times DG. This one is not a difficult task because as long as you have proven that your triangles are similar, you are always able to write out specific statements. So as long as your triangles are similar, right, you know that the following is true. DG over DE, so we have DG here over DE is equal to GE over EF. GE over EF. And then this is equal to DE over DF. Fine. The reason here is just proportionality theorem. Now with these statements, right, we have to choose 2 of them that at least have these dimensions, lines. So there's DG somewhere. There's DG here. We need something with DE. These 2 both have DE, so that's our, yeah. These are the 2 we're gonna pick. So here we can say DG over DE. Come on now. Is equal to DE over DF, and then we're gonna cross multiply DE times DE going to give you dE squared, dG times dF. It's going to give you dF dot dG like they want us to do here. You see, that's why this is just a 2-mark question, because I mean, like, you're literally just doing something that is just basic and straightforward. So let's move on to the next one. They want us to prove that y squared plus y is equal to 1 for 5 marks. Wow. What a wow. What a wow. So yeah, this question doesn't look like it's playing games, but well, the only thing that we have that has y in it is the fact that dE over dF is equal to y. What we also have is that EH over HG is equal to y. What we also have that is equal to y is the factor is dF over FG. You see, because it's equal to this is equal to y. So it means dF over FG is also equal to y. So let's write it down. dE over FG is also equal to y. So many things here are equal to y, right? And yeah, we can basically start somewhere there. So the other thing we know is fine. Let's think of our previous statements here. We have, let's see how many of these we have. There's D, DE, and DF. So this is, oh, all of these are equal to y technically, because here we have DE over DF. So it means technically that even this GE over EF, GE over EF is also equal to y. And it means that DG over DE, DG over DE is also equal to y. Wow, so many things equal to y. Oh my goodness, this is gonna be crazy. Very, 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 very crazy. Because I mean, like, for 5 marks, anyone would be wondering, okay, fine, it's a 5-mark question. And I mean, like, so far so good, right? We've been going through different kinds of questions that we've been going through. And I feel like this is like low-key, like maybe even like the first one that's like, you know, it just looks a bit crazy, especially how everything that we have just stated now, there's nothing that's like wrong, obviously. But because this is more like the last question in your exam, like, you can expect it to throw some serious hands, you know? So you just want to keep a calm head here. Since we know there are so many things that are equal to y, you want to think strategically. You see, when I say you want to think strategically, this is what I mean. Okay, so the idea is, what do we know? What do we know? What do we know? What do we know? Well, we know that this is equal to y, fine. Oh yeah, you also want to maybe even sometimes make use of some of the things that you would have worked out in the previous question. But yeah, to be honest, this question, the way you're going to approach it is not very normal. So let me actually even copy this sketch so that it's close to what it is that we are going to be writing. So the fortunate thing, the one thing that should console you is that this is like the last question, right? So you can obviously expect the last question to be something that is not like simple or easy to work out. It's obviously going to be a question that's like properly difficult. Not like, maybe not properly difficult, but if it's the last one, I mean, like, you can just try and make sure that you've covered everything in your test. And then as long as everything in your exam is like covered, everything that you know, you've made sure that you have filled it in and you've given your answers, you could spend the rest of your time really just trying to figure out what they're asking, but you're really not going to be sad or anything because you already banked your marks anyways. So yeah, so much things, so much information. So they want us to prove that y squared plus y is equal to 1. Well, anything that's going to be equal to 1, remember in this case, we see that there are so many things that are equal to y, right? Now, funny enough, what we know is that y over y is what can give us a 1. Y over y is what can give us a 1, you see. So yeah, that's what I'm going to do. Let's just see what we can finesse here. let's see here. DE squared is, yeah, ne? Whew, yeah, I'm literally thinking of like pausing and then like drawing out the question. But I think it would be interesting to see like what kind of train of thought a person may want to somewhat take when they're gonna work out a weird question like this one. So yeah, it's just weird. I'm literally just looking at it right now and I'm like, Dogo, where do you want to start, my guy? Where do you want to start? And to be honest, yeah, it just seems like a mess. But the fortunate thing is, always try and go back to what you would have just used, you know? So let's even go back here. The reason I'm going back here is because, I mean, we just did that question. So you may be asking yourself, why did they make us do that question? So let's go back there. See, we went back here to our statement. Now, this statement, what we know is that this is equal to y and this is equal to y. Fine, that's a true statement. So you would then be asking yourself, okay, fine, this is a true statement. Where do you even start? Like, what do you do? You know, like, what do you do? So what we can think of is maybe like combinations of lines, right? So let's see, there's DE here, there's DF here, there is DG over here, DG, this whole line here going on and on and on and on and on. Hallelujah, hallelujah, y squared, yada, yada, yada. Let's see here, this is DE squared. DE squared does not really help anyone with anything. Y, if you flip it over, it's gonna be 1 over y. Hooey. This is interesting. If you flip something over, it becomes 1 over y. Yeah, let me just pause and actually think about this question.